So in the last lesson, I spoke briefly about these two identities, and I just want to start with a bit of a warm-up. If I asked you to look at this Venn diagram, could you find me n of A, n of B, n of A or B, n of A and B? Can you find me those? And can you also find me the n of A and the n of A dash? So we'll call them question 1, 2, 3, 4. Okay, that's the same one. We've done it, and we'll call that 5. See if you can look at the Venn diagram and work out what those things are. Okay. Hi, Simone. I see you online. Kia, can you just confirm that you're okay? Is your signal, are you back? I think so. Okay. We called Simone in the interim just to confirm, maybe to message Simone about if she needs to fill in or if you are going to be okay now.
Yes. Hi, Peter.
I think I'm
send a message.
Cool. Awesome. Okay. So n of A is the number of items in A, so that's 4. N of B is going to be 6. N of A or B is going to be 2. Sorry, it's not going to be 2. That's going to be this one over here. What is A or B going to be? So A or B means you can be in this or in both, and I count 1, 2, 3. That's 8. And what is, oh, we know A is 4. What is the number in A dash, or the complement of A? How many items are there in A dash? So if I'm not in A, I must be everywhere else. So I suppose if I really wanted to color this in, I could kind of focus on all these areas. And I count 1. Okay. So I would find that the n of A dash is 8. A question from Busisiwe, how did you get n, A, and B 2? Well, Busisiwe, if you look at the Venn diagram, the area that has both A and B, like if you got a 3, you would be in the event A and the event B, and also a 9. And so there's 2 items in this region. That's why the n of A and B is 2. Okay. Now, the reason I wanted to show you this is many students don't get the connection between these items and these formulas here. So if you notice, n of A or B, that was 8. So that's the number of items in A or B. And that's equal to the number of items in A, so that's 4, plus the number of items in B. And what you notice is that at this point, A and B is greater than the 8, basically. Now, why is this greater? Well, the reason it's greater is when you add A and B together, you double count the middle region, the intersection. And because you've counted it twice, you have to take away the number of items that are in that intersection, which is 2. And so that's why this thing does work. Give me a thumbs up if you get the connection between this additive, this identity from probability and picture. Give me a thumbs up if you follow that. Give me a thumbs down. Okay. And then what can also, cool. Hi, Simone. Simone, I do see Kia in the, Kia, can you just message Simone so she knows, she's in the chat, so she knows what to do? That would be awesome. Thanks. And just give me some acknowledgement in a message that you've seen what I'm saying. Okay. What I have is that if I want to connect this formula, let me first do this. What is the n of S for this sample space? What is the n of S? Now, S is literally the whole thing. How many items are there in this whole sample space? So 1, 2, 3, 4, 5, 6, 9, 10, 11, 12. So there are 12 items in the sample space. Now, I want to know, can you find me the probability of, if you choose a random number from this Venn diagram, can you find me the probability of A? Can you find me the probability of B? Can you find me the probability of A or B? And can you find me the probability of A and B? And I will call this question 1, 2, 3, and 4. And I want you to use what we have seen so far today to help you work out the answer to this. So we kind of had, the n of A was 4, n of B was 6, the n of A or B was 2, the n of A, sorry, this was actually 8. Okay. So what do we think the probability of A is? Well, A was 4. And how many items are in total? There are 12. So there is a 1 in 3 chance, or 4 out of 12 probability, that if you choose a random number from here, you will get an item that is an A. What do we think the probability of B is going to be? Well, it's going to be 1, 2, 3, 4, 6. It's going to be 6 out of 12, because there's 1, 2, 3, 4, 5, 6 out of 12 here. What about 3 and 4? I'll give you some more time for that. I'm going a little bit quickly, I think. I can zoom in a bit, yeah. Okay, so what I want to suggest now is that A or B, it's going to be 8 out of 12. and A and B is going to be 2 out of 12 because there's two things here. Now, what I want to show you, and it might not surprise you if you've seen that thing coming, but this is how this formula is connected. So if you look at the probability of A or B, it's 8 out of 12. So that's this one. And then that's equal to the probability of A, which is 4 out of 12, plus the probability of B, which is 6 out of 12. So I've done those ones, minus the probability of A and B, which is 2 out of 12. So 4 plus 6 is 10, minus 2 is 8. And so that's how the additive rule for probability is working here. Now, the good news is if you've got a question where they give you any three of these, you can work out the fourth one by just doing which one is missing. So if they give you like this, this, and this, you can then find that or any other combo. Give me a thumbs up if you followed how this drawing down here is connected to this identity up here. Okay, fantastic. And even if you're unsure, don't worry, you can always go back and do it again. For number 5, I want to know what is the probability that you choose an item from that's not in A, or the complement of A. What is the probability that you choose an item that is not in A? So you're going to be out of 12. How many items are not in A? Well, we worked it out over here. It's just going to be 8 out of 12. And so another identity that we often use in this topic is this one over here called the complementary rule. And if things are complementary, right? Complementary. If they are mutually exclusive, or they don't overlap, no overlap. And if they fill the entire area. Now, A and B are not complementary. A and B are not mutually exclusive. There is an area where A and B can occur at the same time. But if we talk about A and A dash, they are completely, so here's A is the yellow, and then A dash is literally going to be everything outside that. And so the yellow and the blue together are complementary. They fill the sample space. There's no overlap, and they fill the entire space. Give me a thumbs up if, give me a thumbs up. Thanks, Simone. I appreciate that. Thank you for popping in. Yeah, I didn't know exactly what was going on. Okay. Okay, so we've got the basics. So the main formulas that we need to keep in mind as we go forward today are these formulas. But obviously we're going to focus more on Venn diagrams going forward, but these are always inside or related to the Venn diagrams. Okay, so let's start with this one. I want you guys, girls, to answer this. I want you to say how many in the group of girls do not play netball, and I want you to represent this information in a Venn diagram. So go ahead and do that for me now. I'm going to get some water while we go. So how many do not play netball? That's A. I want to know the answer. And then B, just say done when you're done with B. My Venn diagram looks something like that. And how many in the group of girls do not play netball? Well, 10 play netball. So what we call out here, this would just be N dash, and 17 do not play netball. Okay, question C, are the events play netball and do not play netball complementary? Are they complementary or not, based on what we discussed previously? Yes, they are, because they are mutually exclusive. If you play netball, you can't also not play netball, and they fill the whole sample space. So that's yes. Determine the N of S, where S is the sample set. What's the N of S going to be? So what does that mean? It means how many people are in the Venn diagram. So it's 27. You guys are smashing this. Number one, determine the probability as a common fraction that a girl chosen at random plays netball. What's the probability of N? And then the second one, what is the probability that they do not play netball? And what we would say is we would use N dash. What do we think the answer is going to be there? So we know actually that this is going to be 10 out of 27. And then the ones that do not play netball are 17 out of 27. And that's going to be the probability. Okay, so that was a simple one like that. Give me a thumbs up if you're feeling confident and on the ball. Give me a thumbs down if you're feeling a bit unsure at this stage. Okay, awesome. Okay, here we go. I'm going to give you more carte blanche here to go ahead. I want you to read this question. It says 24 learners in a class were invited to Adam and Nisha's party. 13 learners decided to go to Adam's party. 12 learners decided to go to Nisha's party. And 3 learners decided to not go to either of the parties. I want you to draw a Venn diagram for this first. And then just tell me done when you're done with the Venn diagram. And then we'll talk about, so basically we're just doing the Venn diagram and we'll talk about the questions afterwards, because they're easy once you can do the Venn diagram. Okay, so draw your Venn diagram and then tell me done in the chat when you're done. Okay, so we have, let's say Adam, people who are going to Adam's party, and then Nisha, and then there's some, now we need to fill in the regions basically. And we know 3 did not go to any of them. Now we have a problem We need to figure out how to fill in these spaces. So 24 learners were invited to Adam and Nisha's party. 13 decided to go to Adam's party. So 13 went, 12 went to Nisha's. 3 learners decided not to go to either of the parties. So what I was thinking is, this is 3. The whole sample space is 24. What we now need to figure out is what goes in here. So important. Does that help? Now, what do you think a good first step would be now to try and start figuring out what these regions should be? Who has an idea? I think we did it in the last lesson. It was a technique we used. Didn't we make this thing over here X? So then if I make that X, does that region have to be in terms of X? Flomelo, you are on the money. Yes, 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 yes. We do assume that they intersect at this stage. The reason I know they intersect is 13 learners decided to go to Adam's party, 12 went to Nisha's, and so that's already greater than 24. So because this number is the only way 13, so 13 plus 12 is 25, which is saying that that's more than the number of people in the class. So there has to be an intersection. And if that makes sense, Paul? So this should be 13 minus X, yep. And this should be 12 minus X. And that is the way I do it. But now I still don't know what X is. Can anybody tell me what I need to do in order to start the process of finding X? What do we need to do? We've got all this, we've got the regions. Okay, you can use the addition rule, exactly, or you can use just adding up the regions. So you can go 13 minus X plus 12 minus X plus 3. Those are all the regions here. And we know there were 24 learners in the class. So that's the one way of setting up your equation. The other way of doing it is, if you know 3 are out here, there must be 21 inside here. And so you could also say 21 is equal to 13 minus X plus 12 minus X. And that would be focusing on that. Look, there's 3 outside. In total, there's 24. So I know there's 21. But I'm going to stick with that one. Find X for me. Find X for me. So it seems Oratile and Tati and Impor, you're quite right. X is 4. And if X is 4, well, the good news is we know this is 13 minus 4. So that must be 9. And then here, this must be 8. And now that we've figured out the Venn diagram, these questions are easy. So how many learners went to both or to 2 parties? So either Adam or Nish, wait, how many learners went to the 2 parties? Oh, okay. This is basically saying, how many are there in A or N? How many are there in A or N? So that's just going to be this region over here. So A, you can either go to Adam's or Nisha's or both. So N would be 21 because you go those 3. how many learners went to both Adam's party and to Nish's party? So for B, I want to know what N, A, and N is going to be. They went to both. They didn't just go to one or the other or both. They went to both. So it should be 4. Yes, we are winning. Now for D, we have to make probability to this. So what is the probability if you choose randomly from this collection of learners that the learner only goes to Adam's party? What is that probability going to be? So only going to Adam's party is going to be 9 out of 24. What is the probability that the learner goes to both parties? So that the learner goes to both parties, where would that be on the thing? Only 4 students went to both parties, and there are 24 in total. So there's a 4 in 24 chance. Okay, last one. What is the probability that the learner doesn't go to either of the parties? So if you're choosing one random person from here, what's the probability that they didn't go to either of the parties? So that would be 3 out of 24. Okay, and I see that Linda Zate agrees. Give me a thumbs up if you followed everything we've been doing so far. Give me a thumbs down if you feel unsure about what we have been doing. We're going to take a little break now, but I just want to get a feel for the room. I'm aware it's been a bit quiet, but we've been, going through our work, and I think we've been doing okay. So let's just take a quick little break. Not a very long one, but just a quick, taking care of our brain so it takes care of us. So turn on your cameras if you're able, and let's just start by shaking up our arms. So shake up the arms. Just roll your shoulders a little bit, just loosen them up. You've been sitting, you're probably tense. Roll them forward. Do a little bit of a rotation. As you get looser, you can spin around a bit more. You're clicking like a mouse here. And let's just do some air skipping to just get our heart rates up. So we'll do 20, and we'll do it in 3, 2, 1. Let's go. Five more. 1, 2, 3, 4, 5, and have a seat. Okay, we're not going to do a brain break today because time is a bit shorter than normal. And so I promise I will make it up to you on Wednesday. But for now, because there's quite a lot to get through, I think today we're just going to do the exercise break. So let's go to another type of question like this. What is different about this question compared to the other ones we've been doing so far? I want to know in the chat, what is different about this question compared to what we've done so far? It has decimals. Yes, Kayleigh, I love it. I love it. So this often, and Nomplelo, Vomelo, totally. Venn diagrams can have numbers, okay? They can have numbers inside the different regions. And if the numbers are there, when you add up all of the numbers, they will always equal to the number of items in the sample space. But it's possible to have your Venn diagram in terms of probability. And so what this is telling me at the moment is the probability of A and B occurring is 0.3. So that's what this little region here refers to. Now, if your Venn diagram is like that, then when you add up all the probabilities, okay, what you will find is that they sum up to 1 because 1 is 100% chance. Okay, so using that idea and using what I told you earlier in the lesson, that if you have an identity which says probability A or B is equal to probability of A plus probability of B minus probability of A and B. Now that's a general identity that always will work. Can you use that identity to help you figure out the answer to this question? What probability goes in section 2, which is really just here? Which option do you think is going to be correct? Often students get a bit confused because they're so used to seeing numbers that when they see probabilities, it can sometimes throw them for a bit of a loop. So you know the probability of A is 0.7. So you know that this whole region must add up to 0.7, which means if that's 0.3, this must be 0.4, which is that one. Are there any questions or comments about that one? Okay, well then let's do another one just to see that you're not foxed by this. Let's just have a... so this is actually just a more general question. Which probability should you put on the Venn diagram first? So this is probability of A and B. And normally with a Venn diagram, a very good tip is to always start in the middle. And so this would be 0.3. I want to upgrade, and which of the three is there? It's the answer is going to be C. Now, I want to upgrade this question because I'm going to use my teacher power, and I want to know, using this drawing, what is the probability of A or B? Or if I was using their notation, A smiley face B. Using what's in this question, I want you to figure out the answer to that for me, to test your understanding of Venn diagrams. Now, I guess what I have to do is I have to figure out what goes where. And when I do that, I notice that A or B is going to be adding up these fractions, which should give me 0.9, or there's a 90% chance that I will be in A or B. Give me a thumbs up if you feel like you understand how Venn diagrams can also be written in decimals as probabilities. That's really the only reason I wanted to do this. I just wanted to make sure you didn't get caught in a test where sometimes I've seen students, they understand it so well and they get thrown by this little change. It's the same thing. Okay, cool. Well, then let's move on. We're on the probability highway here. Let's go to, we started this one in the last lesson, so let's go to start one of these. Okay, now, what are we going to do in the second bit now? I'm going to look at Venn diagrams that are showing 3 events. And I'm going to kind of do this first one with you together, and then you'll do a second one by yourself. So it says, during a survey at a certain school, 350 learners were asked about their favorite sport. So in order to make sense of this whole clutter of information, I start by saying, my sample space will help me keep track. And there are people whose favorite sport was tennis, some for rugby, some for cricket. And what's most important is there are some people who like all 3 of these sports. Now, what that means is that when I draw my Venn diagram, I have to have a region where all 3 overlap. So I'm going to start by labeling this T for tennis, R for rugby, C for cricket. And I'm going to start by putting 78 in what we call the intersection, because they've told me that. Now, if I look at trying to use this information over here, why is it very difficult for me to use the 180 like tennis if the goal is to fill out this Venn diagram and summarize this information? Why is trying to use 180 people like tennis a bit not helpful? Okay, I'm just watching the chat, and Paul has made a comment. There are other intersections. Yes. Tati has said, because it's not only tennis, it includes other sports. This is the problem. Yes. The 180 refers to the whole circle, but I want to know what goes in each region. And so actually this bit is not very helpful. What's more helpful to look at is the second collection. And the second collection says 60 like tennis and cricket, but not rugby. So tennis and cricket would be this region here. But when I say that they do not like rugby, they cannot be in the rugby circle. So what that means is that this region must be 60. And so I've used that information to help me figure out a region. If I go to the next piece of information, 54 like rugby and cricket, but not tennis, I'm going to go and say, well, where is rugby and cricket? Rugby and cricket would be here, but you're not allowed to like tennis, which means that this has to be 54. So I've done that. And then 30 like tennis and rugby, but not cricket, that's going to be this region here. So now I've used all these 3. So I'm going to come back to up here. Can you tell me what goes in that region over there? Can you tell me how many students like tennis as their favorite sport only? So you know 180 like tennis, and you have to take away this stuff over here, and what you're left with, which is 12, is how many students have a favorite sport of tennis, and that's it. I would like to know what this region is here, the students whose favorite sport is only rugby. Can you work that out for me? I'll give you a moment. And notice how I'm crossing out the stuff I've used. So this should be 18. What about this one over here? So for cricket, oh, boy, you've got some nice emojis there. For cricket only, we have 48. And what about, are there any students who do not have a favorite sport at all? They're hanging out here in the complement of these ones. Are there any students who do not have a favorite sport at all? So we know there were 350 to start with. So I guess that's the sample space. Can you use that to help figure out who has no favorite sport at all? Okay, lots of students. So what you would do is you would just start subtracting all the regions. And I can see from the chat that we definitely have 50. Okay, now, once you have put things in the Venn diagram, life is so good, ladies and gentlemen, because all the cluttered words are behind us and the wonderful simplicity of mathematics is with us. So how many learners like tennis only? I simply go to tennis and I say, I can see it visually, it's 12. How many like cricket only? 48. There it is. Do not like any of the sports? 50. Piece of cake. Now, we have to connect it to probability. So what is the probability that a randomly chosen learner from the group of 350 likes only rugby, right? So likes only rugby. So let me actually, I'll just write it in English. What do you think that is going to be? Pop answer in the chat. So we know that the possible outcomes are 350. How many ones would be favorable? Well, favorable for this question would be liking rugby only. So it's 18 out of 350, which I can see Owami, Tebogo, or Romelo, you've got it. What is the probability that they like none of the sports? What's that going to be? So same number of possible, different number of favorable. And favorable is in terms of the question. So 50 students do not like any of the sports. And so we say 50 out of 350. And you can convert this to a percentage or a decimal if you like. 1 out of 7, I see, Emmanuel, you're right. Absolutely correct. Okay, so there's very much a system. You work from the inside out. Sometimes you have to make the inside a variable, but I want to see, can you fly solo on a question like this? So let me find, let's find one that's not too hard to, let's do this one. This is from our old exam. And let's see, draw me a Venn diagram to set up the information. And when you're done with the Venn diagram, say done. And we'll look at the Venn diagram together and then we'll go from that. So we're up to exam level now. We're pushing up the mountain. No, it's not the best circle, is it? So as you're doing your Venn diagram, what I like to do is just to tick off or to cross the information that I have used, so I can keep track. Otherwise, there's so much words. It's like if you don't cross them out, you forget kind of what you're doing. Where would I start now? I suppose the 3 is quite. And I suppose I should also put labels here. So let's say rugby, volleyball, and cricket. So I don't think this is very helpful to start with because we don't have enough, but 14 learners like rugby and volleyball, but not chess. "12 learners like rugby and chess." So rugby, you should be careful because it's easy to make a silly mistake. Rugby and chess, so that would be this region, but not volleyball. So you can't be here, so you must be here. Cross it out. 15 learners like volleyball and chess, so that would be this intersection, but not rugby, so that's that one. And now I'm going to go to this one over here. And this is where it gets a bit more exciting, but not that much more, because rugby is 52, so this is just going to be 52 minus 14 and 12 is 26, minus the x. So if I do that with a calculator, what's 52 minus 26? That's 26 there. So we get 26 minus x here. And then over here, so I've done my rugby. Now volleyball is 42. So I go 42 minus 14 minus 15. As long as I'm not making a silly mistake, I get 13, and then 13 minus x. And then here I go 5 learners like chess only. So I actually know what that is. It's just going to be 5. Give me a thumbs up if you followed all that. Give me a thumbs down if you didn't follow it. Okay, so we've done the Venn diagram. How are we going to show that x is 8? What do we need to do? What do we need to do to show x is 8? What's the step? So if I think about last time, I built an equation, didn't I? Now, what sort of equation? Now, if I go, oh yes, Linda, you took the words out of my mouth. Same with you, Tati. So something equals 80. Well, what equals 80? Well, all this stuff equals 80. So, you're going to go 26 minus x. Maybe I should go 3 plus that, plus 13 minus x, plus 14 plus x. Apologies for plus 12 plus 15 plus 5. And that all equals 80. Now, if I clean this up, minus x plus x goes away. And what else do we have? I suppose we've got minus x. We've got an 80. And I've got to get all these ones together. So 3 plus that is 29. Minus 13 is 16. Plus 14 is 30. 42. 57, 62. Oh, I made a mistake. Where have I left something out? Who can spot my mistake? How do I know I've made a mistake? Because it said prove that it's 8. (26 minus x plus 13 minus x plus 14 plus x plus 12 plus 15. If I let's have a look. Because the way I left something out, 3. Okay, I might have made an adding up mistake. So have a quick look and see what you get. See if you can solve for x. I suspect I just added it up wrong in my head. Do you guys get x is 8 when you solve this equation? Tell me what you get. Okay, Toboko, did you get 8? I think I was doing it in my head, and so we're all golden there. Okay, last thing. How many learners like only rugby? So how many learners like only rugby? Well, 26 minus x, but we know x is 26 minus 8, so 18. And then last question for today, calculate the probability that a learner chosen randomly likes at least 2 different sports. Now we know the total is going to be 80. The more exciting bit is how many favorable outcomes are there? At least, at a minimum, 2 different sports. So I think we need all of these guys because at least 2 different, but we also need X because then they're like 3 different sports. So what are we going to get for this total here? Well, this is going to be 12 plus 8 is 20, 35, 49. And there's a 49 out of 80 chance of choosing someone who likes at least 2 different. Can we put the link to the poll in the chat? And then I'll just wrap it up with any final comments. I think we did really well today. We got through a lot of work. Please do be honest and let us know when you are giving feedback about how you found the lesson today. And then we can judge. Okay, I've just launched the poll, don't worry. Okay, cool. Don't worry, there must be some issues. So Satya, we do quizzes on the second lesson of the week. So today is Monday. Yes, it's Monday. And so on Wednesday, we will do a quiz based around Venn diagrams and the beginning of tree diagrams. Okay, cool. I hope you enjoyed tonight's lesson, everyone. I think you did incredibly well. And so, yeah, have a good rest of the week, and I will see you all on Wednesday. Great, Satya. Okay. Oh, and Paul, what is your question? I see a question. How would you go about this problem if you weren't given the N of S? In this case, you'd have to be given the N of S. So the only way that they couldn't is if they gave you something else, and then, but then they would have to give you something else. So it's just not possible. Cool. I think here, if you could just take a screenshot and then put it in the Slack channel. Thanks, everyone.